Alright you guys, this is another visual video on the math. This is the inverse square law, and we've already done this one, so I'm not going to go super heavy into it as much because I did on the other video. But inverse square law mathematically looks like this, where it is I1 over I2 equals D2 squared over D1 squared. And when you're talking about inverse square law, you're dealing with intensity and distance. And anytime you're looking at the intensity, you're talking about things like the Rankine, the Coulomb per kilogram, the rad, the rem, the gray, the sievert, and milli, any of that. Milli Rankine, milli rad, milli rem, milli gray, milli sievert. You're talking about some amount of radiation, like a dose, either to the patient, to a radiologist, to a technologist, to a patient, some amount of radiation that they've received at a specific distance. And we're talking about our distances. You're usually talking about a distance away from the source being your focal spot. You're talking about things like feet, inches, centimeters, but realize that when you have your distances, they have to be equal values, meaning you can't use one as inches and the other one as feet. They either both have to be feet or both have to be inches. They have to be like units in order for that to work. So this describes the relationship of the amount of exposure or the dose that you receive at a specific distance. And the inverse square law states that the intensity of radiation is inversely proportional to a square of the distance from the source, which basically means that the closer you are to the source, you're getting more exposure, more dose. The further you are from the source, you get less dose. So even that little bit of distance you can put between yourself and the source is going to help you as far as lowering your radiation exposure. If we look at this, typically we'd like to use a word problem and then kind of simplify it. If the X falls on the intensity side of the formula, then pretty much you just solve for that. So if we use, I'll try and write a formula up here. I'll go ahead and use the black since it shows up just a little bit better, but let's just make a shortened version and say that a radiologist got a badge reading of 25 millisieverts at a distance of 16 inches away from the fluoro tube. So at 16 inches, he got a reading of 25 millisieverts. If he moved to 24 inches away, what reading would his badge receive? All right, and then we can kind of underline to kind of simplify and tell us what those are. So 25 millisieverts is an intensity. It happens to be the first one that I come across, so I'm going to call that I1. They got that at 16 inches away, so that's our first distance. And do the two go together? Yes, because at 16 inches, that's what they got, was 25. If he moved to 24 inches, that happens to be our second distance. And then what badge reading? That is our X, which is our I2. So if you plug in the numbers, you get 25. Your I1 is 25 over your I2 is your X equals D2 squared. So it's 24 squared over 16 squared. And I always tell you guys the first thing I like to do is get rid of those. So 24 squared literally means 24 times 24. So if I take that and I go 24 times 24, that gives me 576. And 16 times 16 gives me 256. Then I cross multiply. So 576 times x gives me 576x. And then 256 times 25 gives me 6,400. And then I simply solve for x, so I divide both sides by 576. That leaves me x, and then this side, it ends up giving me 11.11 repeating. So I'm just going to cut it after 2 and give it that symbol. And what is that? That is actually my second intensity. And my first one was in millisieverts, so this one will be in millisieverts as well. Meaning if this radiologist were to move to 24 inches away, his dose would go from 25 millisieverts down to 11 millisieverts, and that should make sense because he's moving further back from 16 to 24, so he should get less than 25, and 11.11 is less than 25, so that is most likely correct. All right, now that's with x in the intensity side. What happens if the x falls in the distance side? A little bit different. Same way we approach the problem, but let's say that the problem reads that a technologist texted I texted 18 inches away from the C-arm and got a reading of 650 millirem. And I want to know to what distance would she need to go to drop the reading to 125 millirem. Okay, so let's do the same kind of thing on here. Texted 18 inches away, that ends up being my D1. At 18 inches, they got a badge reading of 650 millirem, so that's my I1. To what distance? That's my second distance, and that ends up being my X in order to drop it to 125, and that's my I2. Okay, so if we set that up mathematically, we get I1, which is 650, over I2, which is 125, is equal to D2 squared, so that's my X squared, over D1 squared, which is 18 squared. If I square 18 to get rid of that first, 18 times 18 is 324. Okay, if I cross multiply, 125 times x squared gives me 125 x squared. Don't forget that, you can't just drop that. And then 324 times 650 is 210,600. And then I want to solve for x. So I divide both sides by 125. So I end up with x squared, because I can't get rid of it yet, is equal to 1,684.8. And I'm not done because it's x squared, so I solve for x. And in order to do that, you take the square root of both sides. So the square root of that, x, square root of x squared is x, equals 41 0.04. I'm just going to cut it after 2. And then it's a distance, so that would be inches. So if that tech moved to 41 inches away, it would drop the badge reading down to 125 millirem. So anytime the x is in the distance side of the formula, the last step is always going to be to take the square root. If x falls on the intensity side, this is not going to be a thing. Only on the distance side, never on the intensity side. Okay? And that is the inverse square law, which basically tells you how much of a dose you would get at a certain distance away from the source of radiation, which typically your source is always your focal spot, whether you're talking about a C-arm, an X-ray tube, a fluoro tube, you're always talking about exactly where the radiation is coming from. And this is the visual video for the inverse square law. Hopefully that helped clear some things up. And if you have any problems or questions, be sure to reach out. Thank you so much.